Hello, this is Sara Poulet, and in this video I will show you how to plot the characteristic curve of a rectifier diode. First, you have to build the circuit like this. This is shown also in the video about the resistor characteristic curve. So, once we build the circuit with a voltage source and a current probe, we can now add the graph, which will be similar to that used for the resistor. And by this I mean a DC sweep graph. So we add the graph. We are interested in the current passing from this rectifier diode 1N4007. So we need to plot the current on the y-axis. We drag the object on the y-axis. Now we need to set the x-axis of the graph. So we click on Edit Graph. We always check that the sweep variable is x, which is what we named the voltage source. Now we need to give the values on the x-axis, the start value and the stop value. First, I am going to plot the forward characteristics of the diode, which should evidence the threshold voltage, which for a rectifier diode would be, for a silicon rectifier diode would be around 0.7 volts. So I would like my graph to start from 0 and end at around 2 volts. Okay. Simulate, yes. Okay, so here we have a curve. Okay, it is a non-linear graph, of course. And you can note that the curve breaks away from the x-axis at around 700 millivolts, which would be 0.7 volts for a silicon diode. Therefore, the forward characteristics make sense. Let's plot the reverse characteristic now. I'll decrease the size of this graph a little bit so that I can do another one near it for the moment. So I call another DC sweep graph. I still want to plot the current on the y-axis. This is a characteristic curve. But now I would like the reverse characteristics of the diode. So I need to change the range of the x-axis. My start value will be at around minus 1.2 kilovolts, because from the datasheet I notice that the reverse breakdown voltage for the rectifier diode 1N4007 is around 1000 volts, 1 kilovolts that is. And so I need to plot negative voltages until the 0 volts. Simulate. Okay, so these are the reverse characteristics of the diode. As you can see, from minus 1.2 kilovolt up to 0 volts. And as you can note, rightly so from the datasheet, at around minus 1 kilovolt, the diode is in reverse breakdown. Now, if one wanted to plot these two graphs on the same graph, all you need to do is give the whole range for the x-axis, that is from minus 1.2 kilovolts up to around 2 volts. However, it will be a little bit difficult to investigate the details of the graph. Alright, so here it is. As you can note, the 2 volts is too small here to observe. So it would be best to divide the graph into the forward characteristics and the reverse characteristic separately.